This example is going to cover probability distributions. And so a probability distribution is essentially just a table that gives the probability of having each one of those responses for that variable. And so in this example, the frequency table that we're given, so this one right here, it gives the results of 2,000 families that were interviewed and asked how many cars they have. So for example, in this first row, 30 families responded that they don't have a car, right? And we are asked to find the probability of a family not having a car. So what is the probability that a family has no cars, or what is the probability that a family has one car? And so that's what we're going to do in this table here, right? And so to find the probability that a family does not have a car, we're going to use that relative frequency rule that we learned when we were learning probabilities. And so here, the relative frequency rule just says, okay, take your frequency. So 30 families said that they did not have a car. And then you're going to divide by the total. So 30 out of 2,000. And when you do this, you get 0.015, which, when you convert this to percentage, is 1.5%. So the probability of a family not having a car is 1.5%, or 0.015. And so I'm just going to keep doing that for the rest of the responses for the variable number of vehicles. And so the probability of a family having one car is going to be equal to 470 divided by 2,000, which is 0.235, so about 24%. Probability of having two cars is 850 over 2,000, which is equal to 0.425. Probability of having three cars is 490 over 2,000, which is equal to 0.245. And then the fourth one, or the fifth one actually, the probability a family can have four cars is equal to 160 over 2,000, which gives us 0.080. And so this is what the probability distribution would look like. And so for this question down here, what does this look like? It is essentially the exact same thing as a relative frequency table. And essentially it is a relative frequency table, but we're calling it a probability distribution now. So now let's talk about the properties of these probability distributions. And so if you look at this first property, it says that each value is assigned a probability. But more than that, it says each distinct value. And so what this means is that the very first thing that you should do is make sure that 1, your variable is discrete, and 2, each value is distinct, right? That one value does not show up more than once. The second property of probability distributions is that when you add up all of your probabilities, you should get 1, or if you're doing it percentage-wise, 100%. And so if we look at this example, we need to determine if each of these probability distributions is valid. And so in my first example, let me check and see if my variable is discrete and if each value is distinct, right? So 1, 2, 3, 4, that's countable, it's discrete, and nothing shows up more than once. And so now I need to check the probabilities. And so one thing that it doesn't point out up here is it doesn't talk about the properties of probability itself. It's just talking about the properties of probability distributions. And so before you add these up, you should make sure that all of the probabilities themselves are valid. And so here, all of these probabilities look totally valid, and so I'm going to check to see if they add up to 1. So when I do the addition of each one of these, so I add that one, add this one, and add this one, my result is 1.18, which means that this is not valid, right? Because I'm getting a probability greater than 1, which is not possible. In part B, my variable is discrete because it's countable. Everything shows up once, 15 through 19. But when I check my probabilities, so before I'm adding any numbers together, I'm going to make sure that all of my probabilities are accurate or valid. And when I check this one, I see negative 0.04. It's impossible to have a negative probability, so that means that this is not a valid probability distribution either. So here, I didn't even have to add up the numbers because it doesn't matter if they add up to 1 because of that negative probability. So moving on to part C, when I check to see if my variable is discrete, while it's not in integer order, and what I mean by that is it's not 210, 211, 212, these are still countable numbers, right? I can still count from 210 to 220, 220, 230. I'm just counting in terms of tens now instead of ones, right? So this is a discrete variable, and everything does show up just once. When I check my probabilities, everything is accurate, and when I add them up, I do get 1. And so that means this probability table or probability distribution is valid.